Uh, okay. The yesterday the culture gave the introduction part of Massive 140 and introduce herself to you. My name is Seung Bam. I am the teaching the Massive 140 the online class with Kasha. So if you have any trouble, any question, always write your question on the discussion board or send email to me and Kasha that we can help you. The one more, we can communicate together with the chatting board. So if you have any question, any kind of concerns, could you write your question on the chatting board? I read your questions, I answer your question. So okay, today I want to cover the two sections today. The section 1.6, 1.8. Maybe I have to spend the 1 hour 30 minutes or 1 hour 40 minutes or something like that. I can spend more time because I have to cover the two sections. Okay, I just start the today lecture. Okay, could you see my slide? Could you see my slide? If you see my slide section 1.6, could you write yes on the chatting board, please? Okay. 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 Good. Thank you, all of guys. One more. You can find the lecture note on Canvas. You are going to the module on Canvas. You can scroll down week 1. You can find my lecture note for section 1.6 and 1.8. One more. I will upload my lecture note after finishing this kind of the live session. I will upload my lecture on YouTube and Canvas. You can go to Canvas. You can click record the weekly sessions. You can find my lecture note and you can watch it anytime. Usually I upload my lecture note around the 10:30 or 11 p.m. today. Okay, the section 1.6. The title is Calculating Limits Using the Limit Laws. This is like outline. The first one, I want to talk about limit laws. Second one, direct substitution property. Third one, this is like main part in section 1.6. How can you calculate limit of f of x over g of x as x value approaches a? The first one, we just only try to solve other kind of problems. The last one, I talk about squeeze theorem in section 1.6. After 1.6, I will continue my lecture for section 1.8. The first one, the limit laws. Suppose that C is a constant. The n is a positive integer. The limits f of x, limit of g of x exists. This is like assumption. We have this conclusion. How can you calculate limit of f of x plus g of x as x value approaches a? You can distribute limit to f of x and g of x, the limit of f of x plus the limit of g of x. Second law, difference, same things. Limit of f of x minus the limit of g of x. Third one, limit of c times f of x. You can take out c, just c times limit of f of x. The limit of f of x times g of x, you can distribute limit to the function f of x and function g of x. Limit of f of x times limit of g of x. The fifth one, limit of f of x over g of x as x value approaches a, similar. you can distribute limit to the top and bottom ones. So like this. So in this case, we have the restriction, limit of bottom one is not equal to 0. The sixth one, limit of f of x to the power n, the limit is going to inside. Limit of f of x to the power n. What is limit of c? So what do you think? So could you write new answer? So I want to give the problem is like this. So could you write new answer of this problem? Limit of 5. X value approaches 2. What is the answer? So could you write your answer on the chatting board, please? Okay. You think about it. Okay. 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 Yep, good. This is like a 5 because you can draw one graph f of x equals 5. This is like a function. The f of x equals to 5 is exactly one horizontal line passing through 5. This point is like 2. So what happens? X value approaches 2 from the left, 2 from the right. What happens to corresponding function value f of x? The f of x approaches to this point from the left, same point from the right. The y value is exactly 5, doesn't change. So what does it mean? The limit of c is c. What's like the limit of x? Not difficult. Only plug a value into x, a. The limit of x to the power n, x approaches a, same. You plug a into x, a to the n. The limit of nth root of x as x value approaches a, same. You plug the a into x, nth root of a. In this case, we have this assumption. If n is like even, we assume that a is positive. A is like negative, undefined. A is negative, undefined. We need this assumption. The limit of nth root of f of x is same. The limit is going to inside nth root of limit of f of x as x value approaches a. The same. The n is like even, this is like a typo, not a. So function f of x is like a positive function. We need this assumption. Okay. The next one. The evaluate the following limits and justify each step. So how can we do that? So we can use this idea. First one, distribute limit. Limit of 5x squared, limit of 3x, limit of 6. Next, take out constant, coefficient of 5 and 3. The next, only plug 2 into x. You can plug 2 into x, 2 square. Plug 2 into x, 2. The limit of 6 is same constant 6. And calculate, we have 20. The limit of x cubed minus 2x squared minus 3 over 5 minus 3x, same. Distribute limit to the top and bottom one. Distribute limit to the each terms. Limit of x cubed, limit of 2x squared, limit of 3, limit of 5, limit of 3x. So next, you just only take out coefficient 2, so we have it. The next, you have to plug minus 1 into x. You can plug minus 1 into x. So you don't need it. This part, you don't need it. Only plug minus 1 into x. So we have this result and simplify. Negative 6 over 8. So that's it. This is like one idea. The next tip. So we have another useful property for finding limit, direct substitution properties. If f is a polynomial, a rational function, a root function, or a trigonometric function, and a is in the domain of f, the limit of f of x as x value approaches a equals f of a. What does it mean? Just to substitute a into x, we have function value f of a. Please turn off your video and your audio, please. Please turn off your video, your audio. Sometimes you can talk something like that with all kind of things recorded in this video, and then sometimes bothering. Please turn off your video, turn off your audio. Thank you. Okay, this is called the direct substitution property. Evaluate the following limit. This is like a previous example. Do you know this one? Exactly same too. This is a previous one. This is a previous one. But how can you calculate this one? So I don't use the previous method. So what's that? Here. The 5x squared minus 3x plus 6 is like a polynomial. Just to plug a. Only plug 2 into x. So what is the answer? The 5 times 2 squared. Negative 3 times 2 plus 6. And simplify. 5 times 4 is 20. Minus 6 plus 6. Answer is 20. But that's it. This is the idea. The next, this is similar. Don't use previous method, only plug the minus 1 into x. Only plug minus 1 into x. So like this. And then simplify. We have the negative 1 cube is minus 1. The negative 1 square is positive 1. 1 times negative 2 is negative 2. The negative 3 over the 5 plus 3. So we have negative 6 over 8. The 2 is crossed out. Answer is negative 3 over 4. So this is like a whole idea for solving this problem. I can do that. Same. Only plug pi of 2 into x. So here. So we have sine of pi of 2 plus square root of pi of 2 minus pi of 4. So do you know what is sine pi of 2? So could you write your answer on the chatting board? What is sine pi of 2? Okay, 0, 1, 0, 1. What do you think? Yeah, I can write. No problem. Yeah. Okay, thank you. So thank you for the answers. Yeah, you can write. So just don't worry about just only right answer. So don't worry. Don't worry. You're right. The one student said yes, we can use only this like a shortcut. The limit of f of x as x value approaches a equals f of a exactly shortcut. You don't need to separate anything. Yes, only plug a number. That's it. This is the whole idea. You're right. Only use a shortcut. Yeah. Sine pi of 2 is 1. The sine pi of 2 is 1 plus square root of pi of 2 minus pi of 4 is pi over 4. So we have 1 plus square root of pi over 2. That's it. This is answer. Yeah, this is answer. So same thing. If you have any trouble in question, don't worry. Just only write your question on the chatting board. Yeah, I will answer your question. Don't worry. Yep. The next one. How to find limit of f of x? Oh. How do you get? Oh yeah, pi over 2. This one. let me see this one here. You said this portion. Yeah, I can explain it again. Oh, you're right. Yes, you can just place square root to the top and the bottom one. You're right. Yes, like this. Yes, the change. The root pi doesn't change. The root 4 is, yes, 2. This is like a region. Yeah, square root of 4 is 2, not plus minus 2. Always 2. Yep. Okay, this is like idea. Next one. How can you find limit of f of x over g of x as x value approaches a? So we have 4 cases. This is like a case 1. So you always like think about 4 cases. What's the 4 cases? You plug a into here. So we have the 4 cases. Case 1, the non-zero over non-zero, or 0 over non-zero. Another one, non-zero over 0. Last one, 0 over 0. This is like a case 1, case 2, case 3, case 4. Now I want to talk about these 4 cases. How can you solve this kind of problems? Case 1 is non-zero over non-zero. The limit of f of x top one is non-zero. Limit of g of x is non-zero. The non-zero over non-zero. How can you solve? Only use direct substitution property. What does it mean? Only plug a into top one and bottom one, f of a over g of a. That's it. This is the whole idea. The one example is limit x plus 5 over x plus 3. X value approaches 1. You can plug 1 into top one and bottom one. Top one is 1 plus 5, non-zero. Bottom one, 1 plus 3 is non-zero. How can you solve? Use direct substitution properly. Only plug 1 into x. Answer is 6 over 4 divided by 2, 3 over 2. That's it. This is the idea for case 1. The second case, top one equal to 0, bottom is like non-zero. We use same direct substitution property. Only plug a into top one and bottom one. The one example is like this. Limit x minus 2 over x plus 3. X value approaches 2. How can you solve? Only plug 2 into top one and bottom one. Top one has 2 minus 2, 0. Bottom one, 2 plus 3, 5, non-zero. The 0 of non-zero, we can use direct substitution property. Only plug 2 into x, 2 minus 2 over 2 plus 3. What's that? 0 over 5. Was it like 0 over 5? Just 0. This is the whole idea for solving this kind of problems. The third case, top one is non-zero, bottom one equal to 0. So was it like limit of f of x over g of x? Limit always does not exist, undefined. Undefined does not exist. The note, we can use like one-side limit. In this case, you can use left-hand limit or right-hand limit. The one side answer is infinity or negative infinity. Yeah, it's like this. Okay, the one student said, what happens in the second case? You're right. Yes, it's like a good observation, always 0, because f of a, the case 2, f of a is 0, the g of a is also non-zero, 0 of non-zero is, yes, always 0 in case 2. You're right. So thank you for your attention, this problem. So here we are going back to case 3. So we have 2 possible answers, infinity or minus infinity. This is really important thing. I'm going to give the one example. Limit x value approaches 2 from the left. X minus 5 over X minus 2. So how can you calculate this one? You plug 2 into top one and bottom one. So what happens? Exactly 2 minus 5 over 2 minus 2. Answer is negative 3 over 0. So negative 3 over 0. What's that? Here. Non-zero over 0 form. What's the answer? Limit does not exist. In this case, you can decide either one because this is a one-sided limit. X value approaches 2 from the left, infinity or negative infinity. How can you decide? You can use sign is better. So what's it like a top one sign? Top one is negative, very clear. What is bottom one? What's the bottom one? You can use one-sided limit here. X value approaches 2 from the left, this one. So what happens? You can choose one test number. This test number is less than 2, very close to 2. I can choose 1.9. You can plug 1.9 into bottom one. What happens? 1.9 minus 2 is negative 0.1. Exactly negative number. What does it mean? Bottom one is negative. You can check. Negative over negative. We have positive. Answer is positive infinity. This is the whole idea for solving this problem. The one more example is limit X value approaches 2 from the right, same equation. So like this. How can you calculate? Same. You plug 2 into top one and bottom one. The 2 minus 5 over 2 minus 2 is negative 3 over 0. Answer is does not exist. This is like a one-sided limit. You can decide infinity or minus infinity. How can you decide infinity or minus infinity? This is like idea. You can use same thing. One-sided limit. Top one is negative, very clear. What happens? Bottom one. You can use one-sided limit. X value approaches 2 from the right. It's right here. X value approaches 2 from the right. I'm going to choose test number. The right-hand side and close to 2, I can choose 2.1. You plug into here and calculate. 2.1 minus 2 is positive 0.1. What's that? This is positive number. Bottom is positive. What happens? Negative over positive. Answer is negative infinity. This is the whole idea for solving the third case problem. Always use this method. It's the best way for finding limit values. Okay, the next we are going to last case. The last case is top one equal to 0, bottom one equal to 0. The case 4 has sub-cases. The first case, sub-case type 1, f of x of g of x is polynomial over polynomial. How can you solve? Cross out the common factor x minus a. This is the idea. So here, you can plug the negative 2 into x. What's that? Top one has negative 2 square minus 4 over. Bottom one, 2 times negative 2 square plus 5 times negative 2 plus 2. Top one, the 4 minus 4 is 0. Bottom one, the 8 minus 10 plus 2 is 0. Exactly 0 over 0. What's like numerator? Numerator is polynomial. The denominator is polynomial. We have common factor. What's a common factor? X minus A. What is A in this problem? What is A? So could you write your answer on the chatting board? What is A? Okay. 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 Do we have more answers? Don't worry, just write your answer. So yeah. Okay, good. So A is given. This is like A. This is always given. This is like A. You can plug minus 2 into A. X minus negative 2 is exactly X plus 2. This is common factor. What does it mean? You have to cross out common factor. So only factor out X plus 2. X plus 2. 답은 바람아. Factor X plus 2. What is remaining factors? 답은 X squared minus 4. What is this factor? Could you write your answer on the chatting board? Okay. Okay, good. Yes. X minus 2. What is this factor? Could you write your answer on the chatting board? Was it like bottom factor? Bottom, this one? Bottom? Was it bottom? You think about it. Okay. Okay. Okay, you're right. Yes, 2x plus 1. How can you know that? Here, this is 2x squared. We have only x. We need 2x because 2x times x is 2x squared. Constant is 2. We have 2. 2 times 1 is 2 again. Yes, 2x plus 1. So what happens? Cross out x plus 2. The limit x value approaches negative 2, x minus 2 over 2x plus 1. So this is a limit. You need a limit. Only plug the negative 2 into 탑은 and bottom은 again. We have negative 2 minus 2 over 2 times negative 2 plus 1. We have the negative 4 over negative 3. The final answer is 4/3. So that's it. This is the whole idea. Yeah, you're right. You can use your foil it. You're right. Yes. Okay. This is the idea. Like this. The next one, similar. You can plug 2 into 탑원 and bottom원. So what kind of things do we have? Exactly 0 over 0 form. So what's it like a common factor? A is 2. So A is 2. You plug 2 into here. X minus 2 is common factor. So we have limit. X value approaches 2. Here, X minus 2. The bottom one has X minus 2. You need to find other factors. What's this one? Could you write your answer? So what is the one more factor from the top? Could you write your answer on the chatting board, please? Do you have any idea? 2x minus 1 or 2x plus 1? 2x plus 1? 2x plus 1? So x plus 1. Okay. Okay. We can check here. We have 2. Only x times 2x is 2x squared. We already have it negative 2 here. Negative 2. We need plus 1. The negative 2 times positive 1 is negative 2. You can decide like this. The next, how can you factor x cubed minus a? Do you remember this formula? I can write here. The a cubed plus b cubed. How can you factor? A plus b times a squared minus a times b plus b squared. This is like a factor rule. So one more, a cubed negative b cubed. You can factor out a minus b. The remaining factor is a squared plus a times b plus b squared. So what happens? X cubed minus 8 here. So x cubed minus 8 is 2 cubed. You can use this rule. You can factor out x minus 2 times a squared is x squared plus x times 2 plus 2 squared. That's it. So this is remaining factor. So x squared, x times 2 is 2x. 2 squared equals 4. This is the idea. The next, cross out common factor, we have limit. X value approaches 2. 2x plus 1 over x squared plus 2x plus 4. So like this, you can plug 2 into top one and bottom one. So we have 2 times 2 plus 1 over bottom one, 2 squared plus 2 times 2 plus 4. So we have top one is 4 plus 1 is 5. Bottom one, 4 plus 4 is 12. That's it. This is answer. 5 over 12. That's it. This is the whole idea for solving this problem. The next two, type 2. Type 2 is f of x or g of x includes a root function. I can solve the rationalize by using the conjugate with the root function. The conjugate of a minus b is a plus b, only change the middle sign. The conjugate of a plus b is a minus b, only change middle sign. So this is like a whole idea. This is like an example. The same, you plug 2 into x. Here, what's that? The square root of 3 times 2 plus 10 negative 4 over 2 minus 2. The root 16 is 4. Minus 4 over 0. Like 0 over 0. We have case 4. One more. Top one has root function. Top one has root function. How can you solve? The multiply top one and bottom one by conjugate of top one with root function. So like this. Square root of 3x plus 10 plus 4. The square root of 3x plus 10 plus 4. So like this. So what is one? Limit x value approaches 2. You can just FOIL rule. The first one, this one is square root is gone, 3x plus 10. So here, outer, inner, cancelled. Last one, negative 4 times 4 is negative 16. Over here, don't distribute because I will cross out common factor x minus 2 later. You have to keep factor form is better. this one. So we have limit. X value approaches 2. Top one has, this top one is 3x negative 6. Common factor is 3, factor of 3, x minus 2. Bottom one is x minus 2 times the square root of 3x plus 10 plus 4. Cross out x minus 2, limit x value approaches to 3 over square root of 3x plus 10 plus 4. Last one, only plug 2 into x. So what's that? So 3 over the square root of 3 times 2 is 6. 6 plus 10 is 16. Plus 4. We have 3 over the 4 plus 4 is 8. We have this answer for solving type 2. It's type 2. So like this, so we have it. Type 3. F of x or g of x includes absolute value sign. What's like the best way? So we can use, you have to eliminate absolute value sign. This is like idea. The absolute value of a equals a. So if inside one is greater than 0, the absolute value of a is negative a. So if inside one is less than 0. The limit of x minus 1 over absolute value of x minus 1, x value approaches 1 from the left. That's right. Here, you can plug the negative 1, only 1 into top one and bottom one. So what happens? We have 1 minus 1 over absolute value of 1 minus 1. Exactly 0 over 0. Case 4. One more. Bottom one has absolute value sign. So we have 2 possibilities. Absolute value of x minus 1 is just itself x minus 1. So if inside one x minus 1 is positive. So another possibility is negative x minus 1. So if the inside one is less than 0. So less than 0. Here, my equation, the which one? The absolute value of x minus 1 is only top one x minus 1 or negative 1 times x minus 1. Which one? The which one is like right answer from the bottom one. So could you write new answer? Okay. The one student to write on the chatting board. Okay. Okay. You think about it. What do you think? Do we have more answers? Do you have more answers? Okay. Okay. So how can you know that? You can check one side limit. X value approaches what? X value approaches 1 from the left. So here. So we have like this one. 1. X value approaches 1 from the left. I can choose the test number. This number is less than 1, very close to 1. I can choose 0.9. You can plug 0.9 into inside one x minus 1. Only calculate. X minus 1 is 0.9 minus 1. We have negative 0.1. What does it mean? Less than 0. The x minus 1 is less than 0. Here, x minus 1 is less than 0. You choose negative x minus 1. This is idea. So here, limit x value approaches 1 from the left to x minus 1 over negative x minus 1. X minus like a common factor crossed out, just the limit X value approaches 1 from the left. The 1 over minus 1 is negative 1. So what's like the limit of constant minus 1? Just same constant minus 1. That's it. This is the whole idea for solving this problem. Was it like from the right? Similar method. Similar method here. X value approaches 1 from the right. You can choose test number, the 1.1. You can choose 1.1. You plug into inside. What's X minus 1? X minus 1 is 1.1 minus 1 is positive 0.1. X minus 1 is greater than 0, only itself inside 1. So we have a limit. X value approaches 1 from the right, X minus 1 over X minus 1. X minus 1 is crossed out, limit. X value approaches 1 from the right of 1. What is like the limit of 1? The limit of 1 is itself 1. That's it. This is like answer for solving this problem. The similar. You can plug 3. So same. This is exactly 0 of 0 form. So you can just check which one. The itself or take negative. The 3 minus x is positive. The 3 minus x is less than 0. You can decide the which one. So 3 minus x or negative 3 minus x. Which one? Okay. What do you think? So could you write your answer on the chatting board? Which one? So this top one is the 3 minus x or negative 3 minus x. Okay, 3 minus x, the negative 3 minus x. Just write your answer. Don't worry. Just practice. Yeah, it's not an exam. Don't worry about it. Okay. The two kind of answers do we have? The same. So we think about one side limit. X value approaches 3 from the left here. X value approaches 3 from the left. I can choose 2.9. You can plug 2.9 into inside the value 3 minus x. This is 3 minus 2.9, exactly 0.1. 0.1 is positive. 3 minus x is positive number. Here we choose top one. So what's that? This is same to limit. X value approaches 3 from the left. 3 from the left. 3 minus x over x squared negative 6x plus 9. So like this, right? So like this. The next, so you have to cross out common factor. This is exactly polynomial over polynomial. Common factor is x minus 3. You can change it here. You can do factor. So this one is the take out negative 1, negative x minus 3. Here, x minus 3 times x minus 3. You have to cross out x minus 3. Just we have limit. X value approaches 3 from the left to negative 1 over x minus 3. So we have like this, is right? The next, you plug 3 into bottom one. So what happens? So we have negative 1 over 0 form, is right? There 1 over 0 form. So what does it mean? So this is the non-zero over 0. We have this answer, limit does not exist. This is like a one-sided limit. X value approaches the 3 from the right, 3 from the left, 3 from the left. So you can check positive infinity, 1 negative infinity. How can you do that? The same. How is the negative out front if 2.9 is like possible? Yeah, here, you understand this kind of things right now. How can you change this kind of things? Let me see. This is same to the like this limit x value approaches 3 from the left. Top one is 3 minus x, bottom one is x minus 3 and x minus 3. So 3 minus x is different from x minus 3. How can you like cross out x minus 3? Only factor out minus 1, is right? This case is only factor out minus 1. So this one is same to factor out negative. So change it. 3 is same to negative 3. X is same to positive x. The next, the interchange x and negative 3 minus x minus 3. Yeah. This whole thing is positive. Yeah, positive. You got it? Okay. So we have answers infinity. How can you find the infinity, this kind of things? I can explain. Here we can use one-sided limit. 3. X value approaches 3 from the left. You can choose 2.9. So this is the same to top one is negative. Was like bottom one. You plug 2.9 into x. 2.9 negative 3 is negative 0.1. What does it mean? Bottom one is negative. Negative over negative. This is exactly non-zero over 0 form. Answer is positive infinity. That's it. This is the idea. So like this. This is the reason. The next thing. This is like one theorem. The f of x equals g of x. So when x is not equal to a, limit of f of x as x value approaches a equal limit of g of x value approaches a. So this is always true. The second theorem, limit of f of x equals L, if and only if the limit of f of x from the left, the limit of f of x value approach a from the right, exactly same. It's like equivalent relation. So like this. The example, f of x is given. You can determine limit of f of x exists or not. How can you solve this kind of problems? You can check the one-sided limit are same or not. This is like a key part for solving piecewise function. So you need to calculate limit. X value approaches 4 from the left to f of x. You can calculate limit of f of x. X value approaches 4 from the right. You can calculate both one. The limit of x value approaches 4 from the left. What does it mean? X value approaches 4 from the left. X value approaches 4 from the left. What does it mean? The left-hand side. X value is less than 4. X is less than 4. You can use a minus 2x. The next, plug 4 into here. Answer is a minus 2 times 4 equals 0. So we have it. What is right hand side? Limit x value approaches 4 from the right. What's f of x? Like this. X value approaches 4 from the right, this way, the x value is on the right hand side greater than 4. So x is greater than 4. You can choose top on curve. Square root of x minus 4. Same. Don't need plug 4 into x. We have square root of 4 minus 4 is 0. So what happens? The left-hand limit is 0. The right-hand limit is 0. We have same value here. The one-side limit values are exactly same. What is general limit? The same value L. So final answer is like this. Limit of f of x. X value approaches 4 equal to 0. So that's it. That's the whole idea for solving this problem. The next tip. Here. This is my explanation. The squeeze theorem. The g of x is between f of x and hx. X is near a. The limit of f of x, limit of h of x has the same value. What's the conclusion of limit of g of x? Limit of g of x is same value L, right? This is like a squeeze theorem. This is like a graphic, like this. Here, the g of x is between h of x and f of x. We have this inequality. The x value approaches a here. Was it like h of x? H of x approaches to L. H of x approaches L. Was it like f of x? Same. Approach to same number L. So what happens in middle one g of x? The middle one g of x approach to same number L. So we call squeeze theorem. So we can prove this one algebraically. We can use this inequality. Next, take limit. Each side inequality doesn't change. Was it like a limit of f of x? The limit of f of x is here, L. The limit of h of x is also L. So we have it. So middle one is between L and L, the same number. Automatically, limit of g of x is going to L. So we can prove algebraically. We can explain by using geometric graph. Either one is fine for proving squeeze theorem. Here, show that limit of x squared of a sine of 1 of x is going to, what is the answer? The limit of x squared sine of 1 of x. What is the answer? It's like equation. So what is answer? So what is answer? So what do you think? So 0? 0? 0? How can you know 0? Do you have any idea? Yeah, your answer is like 0. Yes, you can use squeeze theorem. The squeeze theorem, so what does it mean? So like this. It's like a graph. Limit of x squared sine of 1 of x is this red one, approach 0. It's very clear. So as like an algebraic method, we can start with sine of 1 of x. So was it like a minimum value of sine? The minimum value of sine is -1. The maximum value of sine is +1. So one more, we need x squared. You can multiply each side by x squared. Like this. So we have x squared sine of 1 of x is between -x squared and x squared. The next is take limit each side. Take limit each side. Was it like a limit of -x squared? Only plug 0 into x. The -0 square is 0. Same. Was it right hand side? Plug 0 into x. the limit of 0 square is just 0. So what happens? Middle one is the middle one, x squared sine of 1 over x is between 0 and 0. 0 and 0. What's like a middle one? The middle one is automatically same number 0. So that's it. So we call squeeze theorem for proving this one equal to 0. We can prove that like this. It's good. It's good. So this is exactly the section, the 1.6. So we are going to section 1.8. Continuity. So what's that? I can follow these outlines. I'm going to explain definition of continuity, the three kinds of discontinuity, the theorem related to continuity, the intermediate value theorem. I can talk about four kind of things for section 1.8. Here, definition of continuity and discontinuity. This is the definition. Function f is continuous at a. If f satisfies three conditions, the first condition, function value f of a is defined. The limit of f of x as x value approaches a exists. The limit value exists. Third one, limit of f of x as x value approaches a is exactly same to function value f of a. The function f is discontinuous at a. What does it mean? If f is not continuous at a. The function f is continuous from the right at a. If f satisfies three conditions, the first condition is exactly same to regular definition of continuity. The function value exists. Second is like different here. What does it mean? The regular continuity x value approaches a. What is continuous from the right? Exactly, x value approaches a from the right. This is the only difference. The third condition is same. The one side limit is same type of a. This is only difference. For one side continuity or regular continuity. The continuous from the left at a, if f satisfies three conditions, the first condition, same. Second condition, so be careful. Here, from the left, x value approaches a from the left exists. The last one, the left-hand limit is same to function value f of a. So we have definition of continuity, definition of discontinuity. Here, I'm going to give you an example. This graph, f of x. So we can check continuity. The function f is continuous at 1. You can check. The function f is continuous at 1. So what do you think? Yes or no? So could you write your answer? The function f is continuous at 1 or not? So yes or no? So could you write your answer? Okay. Okay. You're right. So what's like a definition of continuity? We are going back to definition. You can check. Function value exists, limit value exists, function value is same to limit value. You can just check three kind of things here. What's like f of 1? F of 1 is 2, is right here. 1 has 2. Function value exists. What's the limit of f of x? X value approaches 1 from the left. The the corresponding function value approach to 2. X value approaches 1 from the right, corresponding function value approach to this point 2. So what's the third one? Same value. The function value is 2, limit value 2, same. Yes, f is continuous at 1. Here, the function f is continuous or not? The continuous or not? What do you think? Is it continuous? At 1? No, 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 no. Why not? Do you have any reason? Open circle, the removable disk hole. Yeah, right. What does it mean? What is f of 1? What's the function value f of 1? What does it mean? Open circle. What's open dot? What's it like meaning open dot? Yes, does not exist undefined. Function value does not exist f of 1 undefined. You're right. Yes. Undefined. So what does it mean? Violate the first condition. F is not conditions. Not continuous. Discontinuous. So we have a name of this kind of continuity. We call removable discontinuity. We have a hole, removable discontinuity. Removable discontinuity. What happened to this one? The function f is continuous at 1 or not. It's a third case. What do you think? Continuous or not? No? It's not continuous? No? 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 Yeah. F of 1. What's f of 1? Could you run your answer? What's f of 1? Is it 1? 1? 1? Yes. The 1 is like x value. Exactly. Close that. Yes. 1. The f of 1 is 1. What's the limit value? Okay. Could you write? Yes. Could you write your answer? It's good. This is like a 2. Here, x value approaches 1 from the left to from the right. The function value approaches 2. Open that. Yes, 2. We have a 2. So what does it mean? The function value is different from limit value. F is discontinuous. We have a name, removable discontinuity. We have like a hole, the removable discontinuity. Here, the function f is continuous or not? The function f is continuous? No. The which condition is violated? The first condition, second condition, or third condition? Which condition? The first condition, function value exists. The second condition, the limit value exists. The third condition, the function value is exactly same to limit value. The which condition is violated? Third one, or second one? What do you think? The limit are different from the left and right, you're right. Third condition violate, right. Second condition violate, right. The either is fine. Yeah. The exactly same, you can calculate left-hand limit. So what's like a left-hand limit? X value approaches 1 from the left to the corresponding function value approaching 2. What's like a right-hand limit? The X value approaches 1 from the right. The corresponding function value approaching 2, close that 1. What does it mean? The one-sided limits are different. Exactly, the limit value does not exist. So f is discontinuous. So what does it mean? In this case, two one-sided limit different, like a finite number, that we call jump discontinuity. We have some jump, right? The jump discontinuity. We have jump discontinuity. But function f is continuous from the right. This is like a closed dot, is right? What's it like f of 1? F of 1 is 1. What is right hand limit? X value approaches 1 from the right. F of x here. X value approaches 1 from the right. This function value approaches to close dot. We have same number 1. So continuous from the right. Continuous from the right in this case, not from the left. This one. The limit x value approaches 1 from the right. So what happens? F of x is going to positive infinity. 1 from the right. Graph is going up. We have a positive infinity. Limit value does not exist. So f is discontinuous. In this case, we have infinite limit values. We call infinite discontinuous. Discontinuity. So one more. The function f is continuous from the left or from the right. Which side? Continuous from the left or from the right. What is your answer? Could you run your answer? From the left or from the right? From the left, the left, the left. Yep, left, left, you're right. Here, what's the function value? F of 1 is 2. Close that. What happens? X value approaches 1 from the left. This corresponding function value approaches to 2. So we have limit x value approaches 2 from the left. Sorry, 1 from the left. F of x is going to 2. We have same. Exactly continuous from the left. This is like answer of this question. Okay, right now I talked about 3 kinds of discontinuity. Remember, we have like a whole that we call removable discontinuity. We have 2 different one-sided limit. We have jump discontinuity. The limit value is infinity or negative infinity that we call infinite discontinuity. We have 3 kinds of discontinuity. So you already know the one-sided continuity. So here, this is like an example. So from this graph, you can check the function f is discontinuous or not. We think about it here. Discontinuous. Find x value. The what's like reason why this meaning is you can check what kind of discontinuity do you have it. Do we have removable discontinuity, removable discontinuity, add x, the jump discontinuity, add x, we have infinite discontinuity, the infinite discontinuity at x, find x values like this. Then we can start with the -1 here. Continuous or discontinuous and -1. Continuous or discontinuous? What do you think? Only write something like yes or no. The continuous, yes. Discontinuous, no. Discontinuous? Yep, this is, we have whole. You said removable discontinuity. You're right. We have like whole, removable discontinuity. Discontinuity, yes, discontinuous. What is jitter? What is jitter? Was it like a jitter? Okay, going to what? Positive infinity. You're right. Infinite discontinuity at jitter. Like this. What is one? Yeah, 2 one-sided limit different. We have jump discontinuity at 1. You're right. Yes. Was 2 continuous or discontinuous at 2? Discontinuous or continuous? Discontinuous, continuous, sharp edge, you're right. The sharp edge is continuous or discontinuous, the my equation. The sharp edge is continuous or discontinuous. Continuous. Here, this is function value. The limit value is same point. It doesn't matter. We have a sharp corner, but it doesn't matter. The always continuous. Really be careful. The sharp corner, continuous. The continuous was like a 3. 3 is like a jump. Discontinuity at 3 was a 4. Jump discontinuity or infinite discontinuity at 4. So what kind of discontinuity at 4? Jump or infinity? Which one? The infinite, 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 the infinite, the no jump on infinite. Yes, infinite discontinuity. One side limit is going to what? The negative infinity. So we have infinite discontinuity at 4. What's a 5? What's a 5? So what kind of discontinuity at 5? What is infinity? Yeah, because one side limit is going to minus infinity, so we call infinite discontinuity. What's like a jump discontinuity? Jump discontinuity is the two one side limit are finite, but different value. This we call jump. Infinity is one side limit is infinity, so we call infinite discontinuity. Infinite discontinuity. So this is like a jump. Here, the left hand side finite number, the right hand side finite number. Two different finite number will jump at 5. Was it like a 6? Was it like a 6? 6 is, so what kind of discontinuity is 6? Jump, jump, 6 is jump? Really? Jump? 6? Yes, removable because well connected except to one point we have a hole. It doesn't matter. The closer is any place, it doesn't matter. The well connected except to one point we call removable discontinuity at 6. Don't like this. What's 7? You're right. Infinite discontinuity. The right-hand limit is minus infinity. The left-hand limit is positive infinity. We call infinite discontinuity. Oh, you said 5? What's 5? 5 is here. Graph is like this. We have closed that. And like this, what's that? Not connected. The two different one-side limit. In this case, jump discontinuity at 5. It's totally different. What's like removable? Well connected, except one point. We call removable. It's a totally different. Got it? Just like idea. Okay, this is like exactly the one side. This is like the discontinuity part. So one more, the second problem. For each of the numbers stated in part A, you can determine f is continuous from the right, continuous from the left, or neither. So we have this answer like this. The continuous from the right, the continuous from the left. So let me see. Which one has right and the left? You think about it. What's -1? From the left, from the right, or neither? So what happens at -1? Neither? Yeah, neither. We don't have closed that. What's 1? Yes, from the right. It's like closed that here, connected from the left. Connected from the left. Like this. 2, you don't need it. It's like continuous. You can think about 3. From the left to from the right. Yes. Okay. 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 Good. This one connected from the right. What's 4? Good. From the right again. Close that. From the right. From the right. What's 5? From the left to right, what neither? Yeah, neither. The close dot is not connected. 6, close dot, not connected, nothing. That's it. This is the final answer. So we don't have more. Okay, it's like a whole idea for solving this kind of problem. So next, so we think about definition of a continuity on an interval. Function f is continuous on an interval if it is continuous at every number in the interval. The f is defined only on one side of the endpoint of the interval. We understand continuous at the endpoint. This meaning is continuous from the right, continuous from the left. But here, the graph is like this. We call continuous as C. You can choose C is between the 1 and 7. This is like C. This is like a continuous. It's good. It's right. The continuous. What's it like at 1? 1 is exactly continuous from the right, left, from the right, sorry, from the right. What's it like 7? Continuous from the left, right? The function f is continuous on 1 to 7. So what does it mean? The value c is between 1 and c. Between 1 and c, you can use regular continuity. The point is left-hand point, you can use from the right. Right-hand point, you can use from the left. It's like a whole idea for checking continuity on an interval. This is one theorem. So if f and g are continuous at a, and if c is constant, then the following functions are also continuous at a. Sum of two functions is continuous at a. The difference of two functions is also continuous at a. The constant c times f is continuous at a. The product of two functions is continuous at a. The f over g, the quotient form is continuous at a. The one assumption is bottom one is not equal to 0. The one more theorem. The following types of functions are continuous at every number in their domains. Polynomials, continuous in the domain. Rational functions are continuous on their domain. Root functions are continuous on their domain. Trigonometric functions are continuous on their domain. That was the domain. So this is one key part. So any polynomial is continuous on all real numbers because the domain of a polynomial is all real numbers. This is the reason we can use this theorem. So let me see. We have 4 problems. The first one, this is like a root function. You have to find domain. What's it like a domain of function f? You can just solve 2 minus x is greater than y equal to 0. So what does it mean? Here, you can add x to the both sides. X is less than y equal to 2. So what does it mean? Domain is like the negative infinity till 2. We have closed interval like this. So What does it mean? The function f is continuous on domain. Like this, right? This one. Second one, domain of G. How can you find the domain of G? Do you know? Could you write? How can you find domain of G? Do you have any idea? How can you find the domain of G? Could you write your answer on the chatting board? How can you find domain of G? Not conjugate. This is like not limit problems. You're right. The set denominator equal to 0. The factor the bottom one, you're right. Yes. What happens? The bottom one, x squared minus 9, you have to factor. Bottom one equal to 0, function g is undefined. Bottom one is non-zero, well-defined. So what does it mean? X is not equal to 3, x is not equal to -3. So we can draw a real line, only exclude -3 and 3. What's the domain? All real numbers except -3 and 3. So what does it mean? Function g is continuous on each domain. The domain is minus infinity to -3 and -3 and 3. Last one, 3 to infinity. So that's it. The function g is continuous on 3 intervals. So like this. Third one. The same. It's the same, right? You can just solve. The bottom one is not equal to 0. What is domain of H? Could you write domain of H? What is domain of H? What's the domain of H? So do you have any idea of domain of H? All real numbers except 3 and -3, total different here. Not x squared minus 9, x squared plus 9. Just 3. You can plug 3. What happens? 3 squared plus 9 is well defined. No problem. So no problem. 3. What is the answer? All real numbers here. Yeah, all real numbers. X squared plus 9. What's that? So always not equal to 0 for any real number. You can plug positive number into here. The positive number square plus 9 is positive. Positive is non-zero. It's good. So you can plug 0. 0 square plus 9 is 9. 9 is not equal to 0. It's good. You can plug any negative number. The negative number square is positive. Positive number plus 9 is positive, not equal to 0. So what does it mean? All real numbers. This is like a domain. So this is impossible. So function f is continuous on all real numbers. What's like first one? What's the first one? So this is like f of x plus the g of x plus h of x forms, right? You can combination of f of x, g of x, h of x. So what does it mean? You have to find domain of kx. How can you find domain of k of x? You can combine this whole kind of things here. The first one, this one, domain is here. So what does it mean? So all real numbers include 2. Include 2. This portion here. The next one, second one is all real numbers exclude -3 and 3. Just exclude -3, exclude 3, and remaining part. What is duplicated one? The duplicated one is this portion and this portion. So what does it mean? The domain of K is -infinity to -3, open interval, and -3 to 2, half closed interval. You don't need remaining part. This is exactly domain. So function K is continuous on each domain. Each domain. It's the whole idea. So like this. The next one. For what values of the constant C is the function f continuous on -infinity to +infinity? So how can you calculate this kind of things? So we can use definition of continuity here. What's that? F of A is defined, limit of f of x exists, limit of f of x equals f of A. How can decide A in this problem? They're not difficult. How can decide A? Always use breaking point 2. So this is what? 2, 2, 2, 2, 2, like this. You can use it, the breaking point. So which condition do you want to use for finding C? The first condition, second condition, third condition. Which condition is good for finding C? What do you think? Which condition do you want to use for solving this problem? Could you run your answer? Which condition do you want to use? The first condition, second condition, third condition. Which one? The third one? Third one? Okay, it's good. So one more. What is like the limit of f of x? X value approach to 2. How can you calculate this one? Which function do you want to use? 탑은과 바람은. What's f of x? 탑은과 바람은. Which one? 바람은? 탑은? So we cannot decide. This is like a piecewise function. So what's the best way? Only use second on first is better. But what does it mean? So this part is equivalent to the one side limit same. Limit of f of x, x value approaches 2 from the left is the same to limit of g of x. X value approaches 2 from the right. You can use one side limit value just same. You can use second condition. Here, what is this f of x? What's that? 탑은과 바람은. 탑은과 바람은. Which one? 탑은? Is it 탑은? 탑은? Is it 탑은? Yep, this is 탑은 because one side limit. Here, x value approaches 2 from the left. X value approaches 2 from the left. So what does it mean? So here, x is less than 2. X is less than 2. Yes, 탑은. This is the same to limit. X value approaches 2 from the left. We have cx plus 5 equals limit of what? Sorry, not g of x. Sorry, f of x. X value approaches 2 from the right. X value approaches 2 from the right. X value is greater than 2. You can use bottom on x squared plus c. So next, you can plug 2 into x, c times 2 plus 5 equals. You plug here 2 into x again, 2 squared plus c. So what happens? This is same to 2c plus 5 equals 4 plus c. The next subtract c from both sides. The 2c minus c is only c plus 5 equals c is cancelled just 4. The last step, you can subtract 5 from both sides. The c equals 5 is cancelled. 4 minus 5 is negative 1. So that's it. This is the whole idea for solving this problem. That's good. The next thing here, like this. So let me see. How can you solve this kind of problem? So how can you solve this kind of problem? I want to use like a whiteboard is better. I can use a whiteboard for solving this problem. Just the way I can change the whiteboard. Here. So what's like the problem? The f of x is given. The f of x is like 3 pieces. The first piece, ax plus 5, 4. X is the less than negative 2. Second piece is b, 4. X equals negative 2. The third piece is x cubed plus 8 over x squared plus 6x plus 8. For x is greater than negative 2. We have one more condition. Function f is continuous. Continuous on all real numbers. So how can you solve this kind of problem? Let me see. This is like a more difficult than the previous example because we have to decide A and B. A and B. The idea is very similar. Only difference is we can use second condition and third condition together. Was it like second condition? I'm going to use breaking point negative 2. The second condition is limit x value approaches 2 from the left, f of x equals the limit x value approaches 2 from the right, f of x. You can use it. So what's that? This one is limit x value approaches 2 from the left. What's it like f of x? Top one, middle one, bottom one. Which one? Could you write your answer? Which one? Top one, middle one, or bottom one? Is it top one, middle one, or bottom one? Here, which one? Top one? Okay, so here is 2. X value approaches 2 from the left. X is less than negative 2, negative 2. So you can use top one. So we have ax plus 5. This one equals limit. X value approaches 2 from the right, exactly. This one, negative 2, sorry. Sorry about that, negative 2. Negative 2, negative 2, negative 2. X value approaching negative 2 from the right, x is greater than negative 2. You can use bottom one. X cubed plus 8 over x squared plus 6x plus 8. The first one is very simple. Only plug negative 2 into x. The 8 times negative 2 plus 5 equals. But here, you plug negative 2 negative 2 into top one and bottom one, what kind of result do we have? You can plug a negative 2, we have 0 over 0 form. What's like the best way? You just only factor top one and bottom one. You can factor top one and bottom one. So this is same to what? Limit x value approaches negative 2 from the right. How can you factor? X cubed plus 8. 8 is 2q. You can use this formula. The a cubed plus b cubed is a plus b times a squared negative ab plus b squared. You can use this formula. So we have x plus 2 times x squared negative x times 2 plus 2 squared. So what does it mean? Top one is x plus 2 times x squared negative 2x plus 4 over bottom one is x plus 2 times x plus 4. You can cross out x plus 2. Next, you can plug negative 2 into remaining x. So what's the like answer? The negative 2 squared minus 2 times negative 2 plus 4 over the negative 2 plus 4. Top one is 4 plus 4 is 12. Bottom one is only 2. 2 is crossed out 6. We have 6. Don't like this. So what happens? This is negative 2a plus 5 equal to 6. The subtract 5 from both sides. The negative 2a equals 1. Divide the both sides by negative 2. A equals negative 1/2. So we have it. Don't like this. The next, how can you find B? You can use third condition of continuity. Third condition is limit x value approaches negative 2 f of x equals function value negative 2. That's right. So what is f of negative 2? So could you run your answer? What is f of negative 2 from this problem? What is f of negative 2? 6. This is the final things. From the piecewise function b. The p is exactly f of minus 2. What is limit of f of x? What is the limit of f of x? Could you write your answer on the chatting board? What is like limit of f of x? The 6, what, negative 2, negative 2. So what's that? Negative 2? Negative 2? Here, do you know the left-hand limit is same to right-hand limit? This limit value is exactly same to regular limit. The same to regular limit. So here, what is limit value from the right? Exactly this one. And simplify, what is answer? 6. That's right. This case is 6. Exactly right-hand limit, the 6. What's P? The P equals 6. This is final answer for solving this problem. So we are going back to the slide again. Here I explain this kind of things. Like this. So we have it. This one. So next, we have the more theorems. The function f is continuous at b and limit of g of x equal to b. Then limit of f of g of x is exactly f of b. the y, so like this. Only plug limit value into here. Only plug limit value into here, exactly f of b. In other words, the limit of f of g of x is, what does it mean? The limit is going to inside it. This is like true. Another theorem, the g is continuous at a, f is continuous at g of a. What happens in composite function? F of g of x is continuous at a, right? The g is continuous at a. The g function f is continuous at g of a. Composite function is continuous at a. It's like one more theorem. The next is like the last part in section 1.6, the intermediate value theorem. What's like the intermediate value theorem? So we have this assumption. So suppose that function f is continuous on the closed interval AB, and let n be any number between f of a and the f of b, where f of a is not equal to f of b. Then there exists a number c in AB such that f of c equals n. Is that right? So how can you prove this kind of things? I can explain by using the graph. This is like the best way. Here, so we have A and B. So this function value is f of b. This function value is f of a. So what happens? Graph is well connected, continuous here, continuous. So you can choose number n between f of and f of b. You can choose number n, f of a, f of b. I can find corresponding function values. This is n, find corresponding function values. This is like c. So what happens? The c is between a and b. What is f of c? The function value f of c is exactly same to n. We have this conclusion. So one more, similar. Graph is here, like this. This is like A. This is like B. This is f of A. This is f of B. So similar. The function f is continuous, so well connected. I can choose n. N is here. It's like n. So what happens? I will find corresponding function values. 1, 2, 3. We have 3 values. C1, C2, and C3. So what does it mean? C1, C2, C3 between A and B. What is f of C1? What is f of C2? What is f of C3? So exactly same to n. So we call intermediate value theorem. The function f is continuous. You can choose any value between two function values, f of a and f of b. There exists x value in the domain AB such that f of c equal to n. It's like exactly intermediate value theorem. So we have it like this. So what's like application? Application is this one. N equal to 0 from the intermediate value theorem. So what does it mean? So application of intermediate value theorem is like this. Suppose that function f is continuous on the closed interval AB. So this part is exactly the same. F of a times f of b is less than 0. What's like conclusion of this one? The conclusion is then there exists a root c in AB such that f of c equal to 0. So here, what does it mean? The function f of a times f b equal to 0. So one function value is negative, one function value is positive, or positive, negative. Only two cases, is right? I'm going to use it like a first case. So what does it mean? You can sketch the graph. You can choose A and the B. One function value is negative. Another function value is positive. So we have here the f of B and f of A. So like this. What's like a function? Continuous. What does it mean? Well connected. So we don't have a hole, we don't have a jump, we don't have an infinite value. You can connect these 2 points by using continuous function, always passing through x-axis. It's like a C. The C is between the A and B. So what's like f of C? Exactly 0. We have root. This is one good application. How many assumptions do we have? The function f satisfies two conditions. The first condition is function f is continuous on the closed interval AB. This is the first condition. The second condition is f of a times f of b is less than 0. We have two conditions. We have this conclusion. So I'm going to give the last example, this explanation, like this. Here, show that there is a root of an equation 4x cubed negative 6x squared plus 3x minus 2 equal to 0. Equal to 0. So let me see. I'm going to use the intermediate value theorem. Was like the application of intermediate value theorem. I can write here the intermediate value theorem. The like application thing is the first condition, the f is continuous. Interval AB. The second condition is the f of A times f of B is less than 0. What's the conclusion? There is a root C such that the C is between A and B and f of C equal to 0. Just like exactly the intermediate value theorem. I'm going to use this one. How can you use this conclusion? You have to check. The function f is satisfies the first condition, second condition. So if you don't use this kind of things, you have to decide 3 kind of things. First, you can choose f of x. What's f of x? From this equation. How can you decide f of x? Do you have any idea? How can you decide f of x from the equation? What's f of x? So what do you think? Do you have any idea for deciding f of x? No? Okay. Thank you for your answering. Thank you. So do you have any idea? What do you think? Here, we always use conclusion of intermediate value theorem. Here, what's the conclusion? F of C equal to 0. So we can compare this one. The 0 is here. The remaining part is f of C. This is like root of f of C. F of x is left-hand side. So like this. You can guess this one. Function f of x is given. You can check. So this one is continuous or not. So what do you think? This function f of x is the 4x cubed negative 6x squared plus 3x minus 2. So this function is continuous or not. You can just check. This is continuous? Yeah, continuous. Continuous. Why? Why this is continuous? Why? Do you have some reason why the function f is continuous? Yes, polynomial. It's good. It's a good thing. Yes, polynomial. Polynomial. Yes, polynomial. So the function f of x is what? Polynomial. This is a polynomial. So we have one good idea. Polynomial is always continuous on all real numbers. So this is continuous here. The first condition, function f is continuous. It's good. Continuous because function f is a polynomial. Yeah, this is one reason. The second one, you need to find a and b. How can you find a and b? One function value is positive. The one function value is negative. You can decide a and b. The which value has f negative. So you can decide like this one. You can choose one x value, plug this x value like negative number, like this. So which number has a negative number? Could you decide? So which number? Negative 1? Negative 1? Negative 1? It's good. The good choice. I'm going to choose. You choose -1. You can check. f of -1 is 4 times -1 cube. -6 times -1 square plus 3 times -1 minus 2. I don't calculate. This is negative, 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 negative. The sum of all negative number is, yes, less than 0. The another guy answer is 0. It's good. It doesn't matter. You can choose 0. You can plug 0. Yes, negative. Very easy one. Either one is fine. So how can you choose like the numbers? We have infinitely many possibilities. So you can choose 0, -1, -2, -3, -4. It doesn't matter. You can choose any number. You can choose 0 or -1. Good choice. A good choice. No problem. But we have this one. One more. One function value is positive. What is the x value? So what do you think? 2? 2? Yeah, only calculate 1. You can plug 1 negative because 4 minus 6 plus 3 minus 2 is a negative 1. Yeah, 1 is a not good choice. You can plug 1 and calculate. We have a negative number. You can choose 2. Or 4 times 2 cube. Negative 6 times 2 square. Plus 3 times 2, negative 2. So what's that? This is the 4 times 8 is 32. Negative 26 plus 6 minus 2. Yes, this is a positive number. So what does it mean? The f of 0 times f of 2 is less than 0. Yes, that satisfies two conditions. So the last one, by using the intermediate value theorem. So what's that? So we have, there is a root c such that the c is between 0 and 2. And f of c equal to 0. That's it. The root exists. Yeah, this is proof by using the intermediate value theorem. This is like a whole idea. Okay, today is like a very long time, almost a 2-hour lecture. So this is the reason I can cover the two sections together. So anyway, thank you for attending my class and participate. Really, thank you very much. Really, thank you. So if you have any question, just to write your question on the chatting board, I can answer your question. If you don't have any question, you can leave a live session. You're welcome. So I also thank you, appreciate the new attend and participate in my lecture. Really appreciate. Okay, I'm waiting your like any question. If you have any question, just write your question on the chatting board. I will just answer your question. So if you don't have any more question, yes, you can leave live session. Yeah, I just only waiting. Yep. L'Hopitage rule. So we cannot use L'Hopitage rule in mass 140. We can use L'Hopitage rule the mass 141. So you can learn the L'Hopitage rule the mass 141. So mass 140 we don't use the L'Hopitage rule. Yep. You're welcome.